The seventh and final index law that we're going to look at deals with, I guess, a combination between index law number 5 and index law number 6. And this law states that if I have a raised to a power that is a fraction and is negative, then this is how it's going to behave. The negative is going to put it on the bottom of the fraction. The denominator of this fraction is going to tell me the root that I'm dealing with, so it's going to be the nth root. And the top of the fraction, the numerator, is going to end up being the power that ends up down here. Now, that's really confusing. Where do all these bits and pieces go? But it makes a bit more sense if we think about it as separate rules. And in fact, you don't even need this rule. You can just get to this result through a series of steps, a series of applications of the previous rules. So I'm going to do an example, and I'll show you two ways that you can do this. I'm going to pick some numbers here, x to the power of negative 3 halves. That, okay, if I go straight from this rule, the negative is going to put it on the bottom. The 2 at the denominator, the 2 is telling me what sort of root I've got. So this is a square root. And the 3 on the top makes it x cubed underneath that square root. That's the quick method using this law. If you're a bit lost on that, it's sometimes helpful to do it the long way until you sort of become familiar with how this is going to work. And I'll show you the long way. X to the power of negative 3 on 2. Okay, I can write that as x to the power of 3 on 2 all to the power of negative 1. Now, if you're not sure about that, stop the video and just have a think about that. This 3 on 2 times the negative 1 by my index law number 3 would end up back at this step, because 3 on 2 times negative 1 is negative 3 on 2. I've just written it in a different form where I've got some power all raised to another power. Now, I can actually break it down one step further. 3 on 2 is the same as 3 times a half. So by the same logic, I'm just going to put this here to the minus 1. I'm not worrying about that minus 1. I'm just breaking up what was inside those brackets a step further. I can write what was in those brackets, which are a bit too big there. There we go. I can write 3 halves as 3 times a half, so I can rewrite this middle part here as x cubed to the power of a half. So that bit that I've underlined red there is the same as this bit that I've underlined red here. Okay, again, you can check this. 3 times a half is 3 on 2. So I could go back again this way if I wanted to, but what I have basically here is that this whole statement here is equivalent to the first one that I had. Now let's have a look at what we've got here. X cubed all to the power of a half. I know from index law number 6 that something raised to the power of a half is equivalent to a square root. So this here is equivalent to this thing to the power of a half is equivalent to square root of x cubed. The thing in here is just under a square root sign instead of a power of a half, and that's all raised to the power of negative 1. Using index law number 5, negative powers put things onto the bottom of fractions. Okay, so a to the negative 1 would be 1 on a to the 1. So this is equivalent to, because it's a negative power, it's equivalent to 1 on the square root of x cubed all to the power of 1. Power of 1 is just the same, doesn't change it. So I don't need this 1 here. I can write this as 1 on the square root of x cubed. And let's check. Yeah, it's the same as what I got from doing it the shortcut method using this index law. So I guess this index law number 7, it's kind of just the most complicated expression you could imagine. It's a combo of a bunch of different index laws applied one after the other. And I guess this law just illustrates that you've got to be on top of your index laws. You've got to be able to work out how they interact without even thinking about it. I'm happy for you to use the law if you'd like to get straight to the answer, but if you get confused and you're not sure, you can always break it up into a series of simpler steps, even though it might take you a little bit longer. I hope that's helpful. We need to make sure that we understand these index laws so that we're able to simplify more complicated algebraic expressions.